and just a second. Now it works. So probably I try to make recording of all the lecture and publish these recordings to be available for you using the vcamp and using other resources, or other public stores, public resources that I can use, and I am allowed to publish the lecture to make sure that you can get back to the lecture and recall some basic terms from the lecture. Actually, I don't have any presentation, so any question to publish also the presentation, it's I don't know. I don't have presentation. I have only a few slides for today, but that's all. Usually we'll work with on examples on the code with the program, because I'm going to talk about the programming technology, so we must explain what the programming means and what the technology means. It is my goal for today to explain both terms, and also other terms. I'm pretty sure that most of the terms you are familiar with, but it is kickoff meeting, therefore it is good place to recall some basic knowledge, some basic terms, to make sure that we will be on the same page starting work. More sophisticated solutions, sophisticated constructs, sophisticated tools and approaches and technologies, because we spend a lot of talking about the technologies. First thing about the technology is that technology will change. So but my goal is to provide you universal knowledge, the knowledge that you will use for years, not only for the next couple of years, for your life, for your professional career, for 10, 20 years. It's very difficult to talk about things that will be useful in 10 or 20 years. In case of the computer science and the information technology. Therefore, but still is my goal. I'm not sure about possibility to meet these requirements, but still it's my goal. I try to fulfill this request. So let's get started. Basic rules you probably know from the previous lesson. Even though if you are going to attend my next lesson, laboratory lesson, so we'll get more about how to be graded, how to pass, about the requirements, formal requirements. I don't think that the lecture is a good place to waste time to discuss things like that. Therefore, let's try to answer the basic questions but one of the rules of this lecture is that you should be active. How to measure the active? It is very difficult to measure things like activity. I try to measure it by asking some questions. I will ask questions for you, and you will try to answer this question using the chat. After that, I will review all your responses and filter all of the bad responses, filter out all of the bad responses, and provide only for one question, one response that will get activity point that you can use as scores for your grading. So let's try how it works. Let's ask you first question. What do you think? What does computer science mean? I'm putting this question on the chat. try to answer this question, but try to start answering, start your statement from about, all about, and provide only a few words. All the questions are very simple. Of course, we are not able to measure simplicity. And usually the simplification is not it's not a matter of simplicity, but try to answer all the question using only a few words. I am expecting, in most of the cases, a few words. Information technology, computer science, software engineering, you can see on the screen. I hope you can see my screen. If there is something wrong with that, you can switch on your mic and interrupt me. If there is something that I need to explain because if something is not clear for you, just switch on your mic and interrupt me and ask me about it. So we have this three terms: information technology, computer science, software engineering, and the question is what it's about. Researching the Google, I find the answer: the systematic handling and processing of information with computers. It is the answer. So let me ask you next question. I see that there is a lot of answer for the previous one, but I must stop discussion. We don't have time. Next question is: do you think it's true? The answer should be yes, no, or depends on. Yes, no, or depends on. The systematic handling and processing of information with the computers. The problem with the definition is on the next slide. On the next slide, you can see the equal sign and left and right side of the equal sign and the question mark. And the question for you is it if it's true? So let me repeat the same question. Do you think it's true? Do you think it's true that the left side and right side is equal? Still, I am expecting answer yes, no, or depends on. So we must address, but using this slide, we must address also correctness of this sentence: systematic handling and processing of information with computers. But let me ask next question. Do you think that I don't have this question on my list, therefore I will ask this question to you, but I'm not expecting answer from you. Do you think that information is abstract? Of course, the answer is yes, information is abstract. So the problem we have with the previous question, with the previous statement, that it's processing of information with computers, that information is abstract, but computer is a physical device. Therefore, the question is how to process something that is abstract using physical machines. It's impossible. It's impossible. Therefore, maybe it's true, but we must add something, and we must especially address the definition of the terms of information, what the information is, how to recognize information, how to understand information. Let's get back to this slide. So if the left side is equal to the right side, I asked this question previously. Let's stop this now. Let's stop this discussion. Stop. It depends on. Of course, the answer is it depends on. If you are talking about the syntax, so if we are talking about the characters, of course, the left side is not equal to the right side. On the screen, we can see characters. It is lexical. It is lexical level of the discussion. But if you are talking about the meaning, we are talking about the semantics. We are talking about what means the left side and the right side. Of course, if the left side means number 4 and the right side means number 4, in this case, the equal sign is correct, is valid. But we must distinguish two levels of the discussion, lexical level and semantics level. If we are discussing about characters, if we are talking about text, of course, the left side is not equal to the right side. If you are talking about the meaning, maybe left side is equal to the right side, but it depends on. Now we must answer the question, what is the most important thing that we can use to make sure that everyone on the call, left side will recognize as the number 4 and right side also recognize as the number 4. Probably you know this from the previous lectures. It's coding system. The answer is the coding system. But let me ask the next question about you that it's similar to that. What is algorithmic process? Because in the definition we have the word process. So you must also answer this question. What's the algorithmic process? What the algorithm is? But talking about the information and talking about the codings in context of the coding system, we must talk about the representation. We must talk about the representation of the information, physical representation. So in this case, having the number 4, we can represent this number using different languages, using different coding systems. And depending on the coding system, we are using different characters. Using different characters, we can what we can get this way, we can get physical representation of something that is abstract. And in this case, applying the coding system, actually we can use physical machines to process abstraction, provided that the abstraction is represented in a physical by a physical representation. It has physical representation. But why it is so important for us? Next, it is for you questions. In the meantime, so yeah, I will get back to the algorithms. But in the meantime, try to answer this question. Do you feel that you are computer science students? Probably the answer is it's clear for all of you, but still discussing about the information, we must get back to the algorithms. So what we are going to talk about? First, we are going to talk about information representation. If we have information representation, it is the first step that we can use physical machines, that we can use computers for processing. Of course, systematic approach to this process, it is it's next topic for us. It is question about the role of engineering in this process. But why we need different representation? Why for us it is very important how the representation, how the representation looks like? Because usually the information sets are infinitive. So the number of, for example, the number of numbers, it's infinitive. But using physical computers, we must narrow the set of possible values to values that can be represented. And depending on the representation, the processing information processing, now we can say information processing could change. But if we need different representation, we must distinguish two things. Let me open my this, okay. So I can draw something on this screen. No, not this one. So we can distinguish that here we have abstraction and we have representation. For computer users, doesn't matter. It could be the same. Number 4 representation. Usually we are using native language, so we can put any number of on the paper. There's no problem for us. But for the computer, it makes problem. Therefore, we must distinguish these two things, these two terms. And this where we are talking about the number, not sure if I can write. We are talking about information. In case we are talking about the representation of this information, let's say here we are talking about the data. Data, it is something that can be processed, actually that can be processed by the computer. Therefore, for us, it's very important to talk about the data, not about the information, because the information is abstract. So let's get back to the algorithm. What the algorithm is. Not sure about your answer to the algorithm, but algorithms is like a knowledge. It's just a knowledge. It's knowledge how to solve the problem. It's all about how to solve the problem, but it's abstract. Still, it is abstract. It is like information. Therefore, we cannot directly use algorithm to instruct computers, physical machine, what must be done, how to process the data. Again, we must represent this information. Now we are talking about the algorithm. Represent to provide physical representation, for the computers. If you are talking about the representation, in any case, it doesn't matter if it's algorithm, if it's information that it's input or output data that makes input or output data for the processing. So if it's used for processing, we must talk about the characters. In case of the native language, we have all the characters we can use makes alphabet. makes alphabet. But computers cannot use native language. Computers cannot use native language, cannot use native alphabet, because the computers are binary machines. Computers are binary machines, so you can see here. Where's my mouse? Sorry, but I must clear it. Here you can see that using the computer, we must use binary words. Using binary words, we must use binary alphabet. What the binary alphabet means? Binary alphabet means that doesn't mean it's 1 and 0. It is set of 2 characters. Yes, it's set of 2 characters. Doesn't matter which one characters. Not only 1 and 0. 1 and 0 we are using on the paper, but computers use different characters. But always it uses only 2 characters. And we must construct, we must join together many bits to create coding system, to create a representation of this information. So actually, in this representation, we have 2 sets. One set is the information set, and second is representation. And we must provide a relation between the information and the representation of the information. Therefore, talking about coding system, we must talk about 3 things. I'm not sure if it's on the next slide. Okay, it is questions that summarize our discussion. So, talking about the representation, we need creating coding system. We need 3 things. First, it's alphabet. Alphabet means that we are dealing with well-defined set of characters. For the computer, we are using 2 characters, only 2 characters in the alphabet. Talking about the native language that is similar to the native language, we are talking about the alphabet that contains many characters depending on the language. Second, what we need rules. How to couple together characters to make valid words, valid sequence of characters, valid sentence. It's syntax. So syntax rule we can apply syntax rule to validate correctness of the series of characters. For example, we are talking about the binary representation, binary coding system. Let's think about the simple syntax rule. One of the rules we are using, because we can interconnect only, we can use only 2 characters. It seems that it is difficult to provide any validation rule. One of the rules we are using is length of the word. For example, if we are talking about 32 bits words, it is syntax rule. It is one example of the syntax rule. In native languages, it is more difficult. We are using many approaches to describe these rules, but still we must talk about the syntax. But as I said previously, we need also provide information about the relation between the representation and the information. This relation we call semantics. So semantics rules describe how to assign to the valid stream of characters, how to assign knowledge. What it means, how to say what it means, what this series of characters, stream of characters actually mean. It's semantics. So going back to our definition about the systematic handling of processing. Systematic handling means that if we are going to process information further, we must represent this information, and the representation must be well known. So you must be aware about this information. You must be aware about the coding system. It is your job. Of course, computer user is not aware about it, because usually we are exchanging with the environment information using the native language. Using the native language, actually, we also represent information using the characters, sentences, and at the end of the day, syntax and semantics. But in the computer, talking about the computer, additionally, we must require that the representation is binary, because the computer are binary machines. Therefore, all the representation must be built on the alphabet that contains only 2 characters. Doesn't matter which one, but only 2. Okay, so we know that processing. Let's get back to the processing and discussion about the algorithm. As I said, algorithm is all about how to solve. So let me ask the next question, because we are approaching this topic. If you feel that I haven't answered any question, just interrupt me and ask me. Now the question is what the programming software development is. What is the process? Don't provide me any essay, that just answer in a couple of words. Remember, I tried that our discussion is engineering one, so don't provide descriptions, just provide a few words. What do you think? What we are doing if you are talking about the programming? Because now we must get back to the algorithm. As I said, algorithm is knowledge, it's abstract knowledge. Therefore, we cannot apply this knowledge directly to the computer, because the computer has physical machines. Therefore, we must represent this knowledge. We must represent this knowledge as the program. Yes, as the program. So the program, in case of algorithms, the program, we call it implementation of the algorithm. Implementation of the algorithm. Of course, next question will be what the program is, but let me get back to this topic later. Now, it is enough to say that we must implement the algorithm using program. Of course, if we are talking about the computer, the program must be binary. It's impossible to use any other languages. Only the binary language is applicable to the computers, because computers are binary machines. But usually we are not using directly binary languages. It is too difficult for us. We are usually we are using native languages. Therefore, we are trying to find how to describe this algorithm, how to implement the algorithm, the knowledge, how to represent this knowledge using the languages are closer to the native language, that recalls native language, similar to native language. But one of the most important thing about this process of processing, because usually people also processing information, writer, scientists, or any students, and any actually people's process also handling and processing information. But the most important thing is that this handling of and processing of information must be in the context, must be using computers, but computers are binary machines. So what is programming? Maybe I have next question. Do you think that is programming development theoretical discipline? It is something that it's theoretical. Of course, I see that all of you are sure that it's no, it's not theoretical. It's practical. It's practical. Therefore, we can call this discipline, we can call engineering. Therefore, we are talking about software engineering, software development, engineering rules. For example, we are using terms like this. So we are talking about engineering of this process. How to make this process to be in all of the cases similar, and actually the goal for us is to make the processing of the information automatic one. So we can use the same computer and the same implementation of the algorithm many times, and using the machine, it is expected that the result will be the same all the time. Of course, it's not true. You know that it's very difficult, but still it's goal. And actually, it's easier to use computers to make the process automatic one than processing by people. So the human aspect in information processing, we can remove human aspect of the information processing. Using the computer, we have actually replaced the human approach. So we are using computer to process the data. Let's get back to the next. So what is programming? What is software development? What is main goal? What is the program? What is the programming language? It is all of this question. It's for us the most important, and I will not try to answer this question during the lecture. I assume that you know the answer to these questions for now. But to make sure that we are on the same page, let's recall the answer to the question, what the program is. I think that we start answering the question was what the programming language is, because usually we think about the programming as using a programming language to implement selected algorithm. So actually, if we are talking about the language, it's like talking about the coding system. We are talking about trying to find a representation for the abstraction, and this representation could be concrete one, could be processable by the computer. So this time we also have three things. We have alphabet that contains letters, that contains characters. not only letters, numbers, and other signs, but it is alphabet. It is first thing we need to know, we need to have. Second is semantics, syntax that provides rules how to couple together all of this, um, all this, if to how to make sure how to validate correctness of the text. If you are talking about the native language, we are talking about the text. So how to prove that the text is correct against the syntax? And of course, we need semantics. We need to understand. We must have rules how to assign knowledge to this. How to assign knowledge to this to the text. So we must provide a relationship between the text and the knowledge of this text. Talking about the programming language, we are talking about the algorithm. Algorithm is this abstraction and must be implemented using this language. We are talking about the language we are using. But as I said previously, computer use binary language. Therefore, we need to convert the language that we are using, human-like languages, human languages that is close to the native, that is based on the native languages rules. We must convert to the binary. We call this process compilation or translation. It could be automatic, but still it's algorithm. Still we are using programs. Still we need programs that converts program high-level languages, high-level programs that we have developed using the high-level language to convert this to the binary representation, using binary language. But what is the difference between the binary language and the high-level language? The difference is of alphabet. Of course, it is the source of all of the modifications, all of the changes. In case of the binary language, we are talking about the binary language, binary alphabet. Having binary alphabet in case of the computer language and having native alphabet we are using in the native languages, we must build completely different syntax and completely. But semantics could be similar because we are talking about the same meaning. Converting the program from the text into the binary representation, our goal is not to change the meaning of this program. The meaning, the program should do the same, more or less, of course. The problem is how to prove that still after compilation the program is responsible to provide the same functionality, the same processing as in high-level language. So what is the program? Program is the text. Talking about the program, maybe it is good topic for the next discussion. So what is computation? Next question is, what is computation? Now we are talking about the design time. We are talking about how to implement algorithm, how to develop a text that we can use for compilation, and we can translate, we can convert into a binary program. But still, we are talking about the representation of the algorithm. We are on the design stage. Answering the question was the computation is, you must remember that now we are talking about the execution time, about the runtime, when our program becomes a recipe for the computer, what to do, how to behave. It is description of the computer behavior, because the process of information processing, actually data processing, it is it is all about behavior of the machine. So actually writing a program, we are writing a recipe for the computer, what to do with the data, how to process the data. So what is main goal for us? For us, the main goal, it is for software development and for programming, actually, it is to develop a text. Finally, we are in the first steps, we are developing the text. It is the first stage. I think it's very important for the practical, for the laboratory lessons, because in the first step, you must to implement selected algorithm. What algorithm you must implement? You can learn from description of the task, so the task, it is just an algorithm. It's abstract. It's expressed. Actually, the requirements for the task are expressed using the native language, and you must convert this description that is in the native language into concrete implementation, meeting all of the requirements. It's not easy task, and actually, because the language, native language, we must interpret native language. But in case of the computer, we must execute the program. So it is very difficult to find a relationship between something that it is interpreted with something that is executed. Okay, it is general discussion, but let's talk about the program. So what is computation? Actually, computation, let's stop on this discussion for now. Stop. Because today you will not get additional points for the activity. It is just an example how it works. But next lesson, next seminar will be, during the next seminar, you will get additional activity points. Therefore, I hope you will be prepared. On the VCAM, you have the schedule precisely. So let's try to be prepared for the topics that are on this list. So the computation, actually, it is the process of running the program. It is runtime stage of the program development, because we are developing the text. It's first stage. Second, it's runtime, so it's execution of this program. Of course, between the finishing the work with the text and starting execution, we must convert our text into the binary representation. We call it compilation. So now I think it's good question is, what is the difference between the text and the program? Where the text becomes program? The answer is very easy. I don't expect your answer on the chat, but probably you know that the difference is that the text must be compiled, so must be errorless in context of the selected compiler, because the compiler is built to check the correctness of the text. So if you are talking about the programming, we have a tool that can be applied to check if the text is valid. After compilation, we are talking about the program. Therefore, the most important thing for us during the assessment process of your work with programs will be compilation. It is the first step, and this step must finished without any errors. If there are errors, it means that we are not talking about program, we are talking about the text. It could be free text, doesn't matter. Only one error, compilation error, it's enough to change the program into just something like newspaper. It's text. So talking about the program, but let's get back to the engineering. Let's get back to the software engineering. Usually, if we are talking about the program, we are talking about the layers. It is very important thing during the task. And usually, you probably know that usually we can distinguish three layers: presentation layer, logic, and data. Three layers. Different. Usually, if we are talking about the layers, we are talking about the responsibility. So the presentation layer is responsible to provide interaction with the computer user. Usually today we are using graphical interface, user graphical interface, but not only. Today computers have many different additional devices that we can use to present any data on the screen, or like a music or something like that, using headphones, using many different external devices. So the representation of the information in this case, this layer is responsible to present the information using the native language. But the native language it's very broad meaning. Not only written native language in this case, also any pictures, any graphics are used to communicate with the users, with the people. So it is in context of human interaction. We are not only using text, we are not only using written language, but also we are using different possibilities to present or represent information. This representation is not formal, not in all cases is formal. Therefore, it is for us it's not easy task how to deal with some requirements of the users, because how to represent information depends on the user. But user sometimes, not sometimes, probably in most of the cases, the users of the programs are not computer science guys. Not only. It is typical scenarios that we are producing program for people that are not computer science guys. Therefore, the requirements how to represent information, the representation must be physical, but it's not formally defined. For example, if you are using graphics, sometimes it's easier, but it's not formal representation. The logic, it is the layer of the program. It's something that is responsible to implement main functionality of the algorithm. As I said, previous algorithm is abstract knowledge, but we must implement it. And usually here, in this layer, we are implementing the most important functionality. Of course, algorithm could also contain requirements related to the information presentation, information representation. If it's sound, if it's graphic, if it's text, it's numbers, or things like that. Of course, this representation depends on the computer, depends on the physical devices we have in the computer. It could be different if we have, for example, computer with the graphical interface, and for example, we have washing machine. Washing machine today also could be a computer, could have computer inside, but the interface is completely different. Sometimes we have represent the same information, for example, temperature. Today you can see on your smartphone's temperature outside on the screen as a number, but sometimes you can see drawing. The same we can represent, for example, on the washing machine. So logic. Next is data. Data layer. Data layer. Data layer. It's responsible to manage access to the data. Usually, if you are processing, let's get back to the previous definition. If you are talking about processing of the information, we are expecting that the processing will be applied to the input data, input information. Of course, the information must be represented, must be provided to the computer, must be entered to the computer using the appropriate representation. But at the end of the day, after processing, we also expect that some information will be not provided to the user, but you will be saved for the, or provided for another computer processing, another computer process, another computer machine, another. So it will be saved for as a temporal information or for future processing. But all the functionality related to this part of the program we call management of the data. Management of the data. But of course, it's functionality. But if you have task, and in the task it's requirement that you must provide three layers. How to prove that actually the functionality is distributed? As I said, it's collected, is aggregated by the layers. It's impossible. Actually, today is impossible. Therefore, talking about the layers, we must talk about something else. Because if you are talking about the program, we are talking about the text. If you are talking about the layers, we also must talk about the text. So talking about the layer, we must talk that the presentation contains part of the text of your program. The question is which one? Which one part of the program should be aggregated by the presentation? Of course, on the one hand, it could be related to the main functionality of this layer. So it's presentation, it's building user interface. On the other hand, you must prove that you have layers. So first, the question is what the layer is. Of course, it is aggregation of functionality. It is abstract definition. It is very difficult to prove that we have aggregated all the appropriate functionality as the layers, but still it could work. But it's not enough. Grouping functionality is not enough for the layers, because the layers need something more. I try to draw something. Not sure if it's, sorry. Not this way, this way. Oh, now. So if we are talking about the layers, let's think for a while what the layer means. If we are talking about the book layers, can we talk about the book layers? Of course we can. We can talk about the many layers, many things. If we are putting one thing on another thing, we have layers. So actually we must expect in this way that this layer use only this layer. So the presentation use only logic. The relation is, there must be a relationship between these two layers, and this aggregation is only one direction. It's impossible, for example, to put another arrow here and say that the logic uses also presentation, because in this case it's impossible to say that the presentation is atop of the logic. So let's array this. It is the only possibility. In this case, it's also the only possibility. So first, talking about the layers, we must prove that we have a relationship between the layers. How to prove? You are talking about the program. It is your homework. Think about it. I try to help you answer this question next, but not during this lecture. It needs. I think it needs answering more questions about what the program is. Not only recognizing the program as a text. It's not enough. We need more details about the text, how the text is organized, because we need in this text construct, aggregation of this construct, and relation between this construct in this language. So we must refer to the syntax of the language. But it is required. If you are talking about the layer, you need this relationship. It is impossible also to provide this relation, because in this case we don't know if for the presentation the layer below is logic or data. Both are on the same level. Therefore, it is also wrong. The only possibility is that the upper layers refers to the layer below and only below. It is the only possibilities of the relationship. It is very important to solve task, for example, task 1. Therefore, it is important to remember, but still we haven't answered the question what the layer is in context of the program, remembering that the program is just a text. But what about the curse? What about the curse? In this curse, we'll talk. Maybe it will be better to start from the very beginning and try to answer the question what the programming technology is. We'll talk about the external data and management of the external data. We'll talk about management of the external data. So let's get back to this slide. So having layers, we'll deal about, we'll learn how to organize, how to manage external data that it's provided to the user. We call it graphical user interface. Therefore, following this name, I call it graphical data. So during this course, we'll talk how to organize graphical data, how to convert the information, the data we have processed using the logic into the graphical representation. But we must also remember about the data that we have presented not only to the user, but we have for the processing, or we have to for saving the state of the processing process, or have to save for the next processing. We are using files and we are using databases. If you are talking about the files, it is, I think it's a good place to provide you an advice, because during one of the next lecture seminar, I will talk about the files. And the question will be what the files is in context of the operating system. Because usually we will talk about the programming, so we will talk about any aspect of how to create text that will be programmed. But we must refer from time to time. We must refer to the external devices that we are using to process the data. Previously, we are talking about the graphical user interface, and I said that it depends on the machine, depends on the external devices. In fact, in case of the files, we are talking about the operating system. Therefore, we must recall what the file is in context of the operating system, because we don't change this. We don't change this term. We don't change this interface, the features of the files in context of the operating system. The only thing I can say today it is that files are streams. Files are streams. But additionally, we are also using to save the data and to manage the external data. It is very important. It is a very important term, external data. In all of the cases, we are talking about the external data, but we are also using databases. What is the database? It is the question we'll try to answer during the next lessons. But talking about the databases, we are talking about the structured data. So the data that has relationship between parts of the data. It's like with the layers, that we have relationship between the layers. Here we have also relationship between the parts of the data. If data is complex and contains many parts, and we need also represent a relation between the parts. Usually we are using databases. In case of the files, we are using streams. But still, in all of the cases, we can use these devices to represent structured data. Okay, let me check if there's another question for you that introduce us. So let's recall what information is. Let's check if you are if you are still with me, if you are still on the same page. What is information? Try to answer this question. Actually, I am sure that I have provided the answer, but now let's check it. And now it is very important thing, very important term, external data. What is the external data? If you are talking about the program and we are talking about the text, we are talking about the design time. But after the end of the day, our programs are ready to be executed using a computer, using a machine. Therefore, we must compile it to the binary form. But still, it's design time. It's not runtime. Still, we are not running our program. Still, in this process, we are just converting our program that it's text, but text that are compliant with the high-level language into the binary representation. But after that, we are loading the process. We are loading our program, binary program, to the computer and executing in the computer. It is very important that today, now, we are talking about the operating system, how the operating system works. Our program are converted into the process. So usually our program is in a file on set of files. Operating system loads all of the files into the memory, creates something that we call process, and start execution of our program in context of the process. So it is just a bubble. It is something that surrounds our program and controls behavior of our program to make sure that interaction between the impact of our program on other program are minimized. There are no real impact between our program and other program, including operating system. So it is very important. But in this context, we must recognize external data. How to distinguish external data from the internal data? If you are talking about the internal data, we are talking about the data that it's controlled by the process, that we can access as a part of the process. External data is the data that we need to get from outside of this process. So in this case, here, what is my mouse? Sorry about this. Here's my mouse. Oh, in this case, during the runtime, we are not talking about the program. We are talking about the process. During the execution, we are talking about the process. So outside data is everything that we have outside the process, that we must use operating system to get access. Because the operating system is responsible to create the process, and our program is executed as a part of the process. And having and if we need access outside of this process, we need to use operating system to use this data. Therefore, we are calling it external data. It is limited. It's not easy. It is a boundary where we are. This boundary that we must build our software atop of, and this boundary we are calling API, application program interface. So the operating system exposed for our program API provides some functionality, And using this functionality, we are getting access to the files, to databases, to the graphical user interface, and other external data. During this course, we will talk about these three parts, these three kinds of external data: graphical data, streaming data, and structured data as the external data. Okay, so let's go to the scope. So we'll talk about the graphical data. It is, I think, our last two lessons. We'll also talk about the structured data, how to manage structured data, how to get access to structured data. Talking about the boundary between our program and operating system, we need to remember that this management process could be supported by different libraries. So it is very important is unification, because it's external data. So for example, we expecting that the same files can be used by different programs, not only for us, not only for our program. The same is with the databases. If you are using databases as external process, external functionality, we expect that the external data, this database, it's the same for many programs. As I said, talking about the files, we are talking about data streams. Precisely, we'll discuss this topic during the next couple of lectures, couple of lessons. But now let me recall that in this case, the data is recognized as streams. Your homework is streams, answering to the question streams of. And why all the files we can recognize as streams? We know that some files could be pictures, could be recordings, movies, could be documents, PowerPoint documents, and things like that. But here I'm trying to say that all the files are streams. Doesn't matter if it's a picture, or if it's PowerPoint document, or if it's a PDF document. To talk about structured data and graphical data and common approach how to manage these kinds of data, we must talk about the functional programming. Therefore, for you, it is, I think, important to recall what the functional programming means. What is different between functional programming and other kinds of programming? It is still programming. What is the most important thing of this approach to the programming? Additionally, we must talk about data semantics. Data semantics, it means how to assign meaning to the data. I've mentioned it at the beginning of this seminar, of this lecture, that building the coding system, it is very important to be aware about the alphabet, to be aware about the syntax, and to be aware about semantics. But in case of the computer, always we have binary alphabet. Therefore, we are not talking actually about the binary representation, talking about the programming in context of the high-level languages. We are talking about more sophisticated terms, more sophisticated concepts that we are using to represent information. Still, the information must be concrete. not abstract, because computer cannot be applied to abstraction, but the representation. In this approach, it is very important. It is very important this sentence, that actually here we can hide some details about this coding system. So it is good. It is good example. It is good example how to prove that simplification is not mother of the simplicity, but rather the abstraction. Talking about the abstraction, actually, we are talking about hiding some details of the implementation. So data semantics is how to assign meaning to our data using type system. You know that today in languages we are using types to represent data instead of coding system. Of course, the introduction, it's obvious. How to make RD, because today I'm pretty sure that you you recognize this lecture as the abstract, this discussion as very abstract. Sometimes I try to get back to the physics. I want to get back to the features of the computer, of the machines, but still the discussion is abstract. Coding system, algorithms, abstraction, and things like that looks abstract. Therefore, I decided that all of the discussion, all of the next discussion, we'll conduct in context of the selected concrete environment. To be on the same page, to make sure that all of us are on the same page, I selected for all of you as the requirement only one environment, language environment. I selected C# and everything that we need to deal with C# languages, with C# programs. C# is language. So my goal is how to turn you as the students to make sure that in the future you will be software developer and actually architects. So I hope that the language, the knowledge and the approach will be for many years, not only for next couple of years, for decades rather. Let's see how it works. To make sure that we are talking about the concrete solutions, I have provided an example, examples, not example. It is repository. Let me open it. Repository that calls C# teaching of programming. Here I'm collecting all the examples, and any examples, any code I am using to discuss selected topics during the seminar comes from this repository. So I think it is the first reference point for you. If there is something that you don't understand, if there is something you don't know how to solve, I think it's first to clone this repository, to open this repository, and to find appropriate topic. Because this repository contains programs for 3 courses. First, it's external data intensive programming. It is actually what we are talking about. I said you external data is data that is outside of the process. Intensive, it means that our goal, it's for this program, for this approach, is to how to manage the data, know how to implement selected algorithms. It's how to get access, how to organize the data, how to read the data, how to write the data. It is that, therefore, I call it intensive data approach. Of course, programming is building text, but in this repository you can also find examples for adaptive programming, for mobile programming, and I hope next will be pair programming. But no, there are no examples. So how to use this repository? In this repository, all the code that's related to this course is in this folder, external data management. Let me make it bigger. Oh, sorry, it's too big. External data management, maybe this approach will be easier. So opening this folder, you can see subfolders related to all of the topics I mentioned previously. It's introduction. In this folder, you can find examples related to object-oriented programming, related to the dependency injection, things that we'll use during the laboratory. Next folder provides example related to the data semantics. For example, here you can find solution, how to solve in program, using the language, how to solve the problem that we discuss on the slide, where we have two coding systems. One coding system two coding system to represent numbers. Here you can find appropriate example. Data streams, it is next topic. How to deal with the files. This answers the question how to deal with the files, but not only with files, because as you know, streams we are also using over the network. If you are going to send the data over the network, we also use streams. Therefore, the streams are a more universal approach, but we'll discuss this approach, how to convert your object-oriented data into the streams. It is the most important topic here. What technology we are using to what technology we are using to convert your object model that we have in the memory into the streams, and vice versa, from streams how to create appropriate structures, objects in the memory. Functional programming, it is more or less dedicated to this language, to construct of this language that supports functional programming, but it's good introduction for the next two topics, structural data and graphical data. Very important thing is structured data. Structured data is all about how to get the data from the databases as structures. So in case of streams, we are representing structured data using the streams. But in case of structured data, we are not converting. We are just communicating with the external devices, but using structured data all of the time. Therefore, it's the most important here is mapping between the structures we are in the memory and structure we have, for example, in the data. Graphical data is all about how to provide user interface, how to still construct the program, and in all of the topics, the most important thing will be what we discussed previously. Let me get back to my presentation, but it doesn't work. Why the layering of the software is so important in context of what I said previously? Because we will talk about the technology in all of the cases, especially if you are talking about the data or if we are especially talking about the presentation here, we are talking about the selected technology. If you are talking about the selected technology, we must remember that the technology could change. It's not that we have forever. Today we are dealing with one technology, and tomorrow probably the technology will change. Therefore, very important thing is how to prepare our program to be ready for change of the technology. Only layering programs could help us, because replacing only one layer, we can replace the layer against the new technology we we must deal with. It is especially important for the presentation for the data. No, still logic must be separated, because usually it will be the most stable part of our program. But remember about next thing, about how to prepare your program to be realized, to be executed using different environment. For example, I mentioned it about the remote computing, about mobile devices, about platforms where we are using many computers to do more or less the same. For example, about the scaling. If you need scaling, if it's not possible to realize logic on the one computer, you must provide solutions that is able to be executed on many computers at the same time. Therefore, having all of the functionality using in one layer, it's easier to spread this functionality on different computers. Oh, I think we must finish, because the time is rolling out. So thank you for your attention. I must switch off the recording. Oh, it's not here. Where is the recording? Okay.